Welcome back. This is the last and final video on what I would call phase one of the coursework. Now, that doesn't mean this is where exam one material ends, but I call it phase one because everything we have learned so far is kind of a collective piece, and you need that collective knowledge as we go into phase two of the coursework, which would be about functional group nomenclature. Okay, so without further delay, let's get started. We've already learned the cis-trans isomers with respect to a double bond. Again, the double bond is the only focus. So since you have learned it, if you just add a little bit more piece of information to it, then it becomes Z and E. Okay, and that's what we're going to do. And again, I'm going to keep the examples to just one or two, because just because I do 200 examples and make the video 20 minutes long doesn't mean I can necessarily convince you to understand it all. You may have to watch a 5-minute video twice rather than spending 25 minutes and not understand the content. So without further delay, what is Z and E? Z and E is exact replacement for cis and trans. However, how we approach Z and E is slightly different, but Z is equivalent of cis, E is equivalent of trans. It's part of the Kahn-Ingold prologue rules. Those are the three things which Z and E is part of. Z itself came from the German word zusammen, means when you have two like things that are on the same side or adjacent to each other, that's zusammen. E is entgegen, means two groups that are alike in some ways, that are opposite to each other, then opposite in direction, that's entgegen. Now, what I mean by like groups is we still assign one or two, and if the one is on the same side, then it's zusammen or Z. If the one is on the opposite side, then it's E or entgegen. Okay, how is Z and E different from cis and trans? Now again, I'm only going to give you the technical quick glance. It's much more easier when you actually see an example in action versus just spending time actually walking through everything. Okay, so in a cis-trans isomers, if you notice, for a cis-trans, there's at least 2 hydrogens is a requirement, it's a must. One must be on each carbon. Okay, that's a cis-trans. In a Z and E, you at the most you can have is 1 hydrogen on one of the carbons and must have 3 different groups, or all 4 could be different and you don't need to have a hydrogen. Okay, how to know when to use cis-trans or Z and E? I've already explained that. That's kind of how is Z and E different is same as how to know when to use it. They're the same thing. So without further delay, let's actually do it rather than just keep talking about it. Okay. You know this periodic table, I've tortured you with it for 9 months in Gen Chem. So it's coming back again just for a short period of time before it goes back into hibernation. The term that we're really interested in the periodic table, if you have not forgotten, this is the atomic number, right? The number at the top. That's what we're interested in. Okay, again, we're not doing any calculations. So you're given 2 compounds. First, you have to figure out whether it falls in the cis-trans domain or Z and E domain. What do? First, I go to a double bond, and just like I did previously, I just put the carbon there just to know I'm focusing here, just where the double bond is. And this carbon is attached to, this bond going up, which in turn is attached to this carbon. This carbon is a bond going through attached to this carbon, and it branches out further and it keeps going. So this bond is going up, which means the hydrogen must be going down. Why? Because carbon must have 4 bonds. This carbon currently has 3. The 4th must be a hydrogen. Compared to these two guys, this is clearly big. So this is 1. This is 2. And similarly, this is going down. So the hydrogen must go up. So this is 2. This is 1. 1 means bigger group, higher priority. 2 means smaller group, lower priority. 1 and 1 are on the opposite side, so this is a trans. Now, why did it fall under cis and trans? Is because we have 2 hydrogens, which is a must requirement. Z and He, you do not ever have to worry about whether something is even going up or down, because it usually is, like I said, 1 hydrogen means you're only more interested in the group itself than whether it's up or down, okay? So I put my 2 carbons here where the double bond is. So I know that's where the focus is. Now, what we are really looking for when it comes to Z and E is direct attachment. That's the words I'm looking for. What do I mean by that? The carbon here is attached directly to fluorine. This is, we know, as a methyl group, right? But again, the carbon is only in turns attached. I'm underlining that so you know. This carbon right here is attached to a fluorine on one end, and the other end it's attached to a carbon. The carbon in turn is attached to 3 hydrogens. We're not worried about that. Only worried about what is these carbon attached to. And if you go look at the atomic number, fluorine is 9 and carbon is 6. Which of these two is bigger? If you add everything, yeah, it's different, but we're not interested in that. We're only interested in the atomic number of the direct attached element. So this is 9 and 6. So this gets the first preference. This gets the second preference. Okay, so higher atomic number, higher priority. Okay. Similarly, on this side, the carbon is directly attached to a Cl, and this carbon is attached directly to a C. You look for the first direct attachment before you start to deviate. We can do more examples in the future in the next clip. But so again, this is attached to this. We're not worried about that. Where is the first point of contact for this carbon next in the series? This is attached to the C on one side and Cl. And Cl is 17 and carbon is 6. So this again gets first priority, this gets second priority. Again, what I'm really saying is the first point of contact. And 1 and 1 are on the opposite side. 2 and 2 are on opposite side. So this is an E. Okay, let's do one more example before the video gets too long. And that's where I want to end connections here and have you practice as part of our My Thoughts series. Again, we put the carbon where the double bond is. We know right away that this carbon is not attached to any hydrogens, and so is this. So it can be a Z or E. So this carbon is attached to a Cl, direct point of contact, and this carbon, first point of contact is a carbon again. So this is 6 atomic number, right? And this is 17. So this will be 1, and this will be 2. Similarly, the first point of contact for this carbon is bromine, which again is a very huge number. So this gets first priority. This is attached to carbon, so that's second priority. 1 and 1 are on opposite side, so it's E. Let's do this. Does it have to be, I said 4 groups, but you can have pairs of 2 identical groups as well, or you can have 1 pair that's identical. Still you can have a Z or E, as long as there's no more than 1 hydrogen. In this case, there's no hydrogens at all. So again, so 2 carbons. The first point of contact for this carbon is fluorine. The first point of contact for this carbon is actually CH3, which contains the carbon. So carbon is smaller than fluorine. So this is 1, this is 2, Again, this is one, this first point of contact is carbon. We're not worried about what this carbon is attached to. Unless you have two methyl groups, which I'm going to show you one. So this will be 1 and this will be 2, so on opposite side. So this will be E as well. Okay, let me do this one so that there's one where you can see that. So this is a carbon containing the double bond. This is the first point of contact, which is a CH3 group, right? But again, we're interested in the carbon. Here again, carbon, right? But this is a CH2 and CH3. Again, the first point of contact is identical, so we look further. Well, this is only attached to 3 hydrogens, whereas this carbon is not only attached to 2 hydrogens, but is also attached to another group. So if your first point of contact is the same, then you look further, and this is clearly big, so this is 1, this is 2. Similarly, the first point of contact here is a carbon. First point of contact here is a carbon. They're the same, so we look further, and these two guys are even bigger. So this will be 1, this will be 2, 1 and 1 are on opposite side, so it's E. Again, as I said, majority of compounds are going to be E, and I want you to practice the 3 compounds that you see that are not unattended. And if you have questions, ask me. We're going to practice this in class. Again, like I said, I can do 200 examples in 10 minutes. Does it mean I can convince you would understand? Probably not. So that's good enough. I'm going to stop the video here, and that concludes our phase 1 of the Chem 330 course.